Hey guys, and welcome back to Maths with Cats. So today we're going to be going over graphs of functions. So let's get started. So y equals kx to the n. This is the first type of function we're going to go over. If n is positive and even and k is positive, the graph will be U-shaped. If n is positive and even but k is negative, the graph will be N-shaped. You can see here with them two graphs. So if there's a positive even power and a positive coefficient U, if there's a positive even power and the coefficient is negative, N. If you think about it, it makes total sense. Think about an x squared graph, for example, and that should make total sense to you. If n is positive and odd and k is positive, the graph goes bottom left to top right. If n is positive and odd and k is negative, the graph goes top left to bottom right. So think of this one kind of like a cubic. Cubic is an odd power, an odd power that's positive, and then positive or negative coefficient works out which way it goes. If n is negative and even, so negative even power, and k is positive, the graph is above the x-axis and both axes are asymptotes. And if n is negative and even, so a negative even power, and k is negative, so the coefficient is negative, the graph is below the x-axis and both axes are asymptotes. So let me show you what that looks like. So this is kind of like an x to the minus, no, that's wrong, an x to the minus 2 graph, something like that. If you think about it, if you have a negative power, it's the same as 1 over something to the positive power, and as x increases, the denominator is going to increase. So the denominator is going to increase, so the overall number decreases, which is why you get the trend shown on the graph. And if it's a negative coefficient, it'll become more positive, but it'll start very negative. If n is negative and odd, k is positive, the graph will be in the top right and bottom left quadrants, and both axes will be asymptotes. So if there's a negative odd power with a positive coefficient, that one is, and the other one is a negative odd power and a positive coefficient. So you get something like this. Quartics. So this is a type of graph we've not covered yet at all. I'm waiting for it to load, it's been a bit slow. Okay, a quartic has x to the 4 as its highest power. So cubic, 2 is the highest power. No, quadratic, 2 is the highest power. Cubic, 3 is the highest power. Quartic, 4 is the highest power. It's a W-shaped graph if it has a positive x4 coefficient. It's an M-shaped graph if it's a negative x to the 4 coefficient. So if you're going to sketch it, you find the roots and the y-intercept to sketch, just kind of like you would with a quadratic. Might also be useful to find a maximum and minimum points, but this will be in a later video, the method for that, because it involves an entire skill we've not learned yet. Here's an example. Sketch the graph of f of x equals x lots of x plus 1 lots of x minus 2 squared. So when you put that equal to 0, so when it crosses the x-axis, x must equal 0, minus 1, or 2, where 2 is a repeated root. They're the roots. The y-intercept is also at y equals 0. If it crosses x equals 0, it must also cross y equals 0. So you can see here, this is what that graph would look like. So you'd plot the roots, so this would be our minus 1, our 0, and our 2. We know that the 2 is going to bounce. We've got a positive x to the 4 coefficients. It's going to be W-shaped. So we're going to go down through the first root, turn around in between, up through the second root, and then bounce off the third root. If a root is repeated 3 times, the graph would flatten out at this point. So kind of like the graph of just x cubed, where that's got a triple root. How it flattens out in the middle, it kind of goes. It would be a similar sort of thing with an x to the 4 graph if there's a triple root. Transformations. So y equals f of x plus c. For positive c, the graph of f of x is shifted c to the left. For negative c, the graph of f of x is shifted c to the right. So you can see here how that works. So the blue is the original one. We've plussed c, and you can see how it's moved. Now, because this is a repeated graph, you can see we don't actually know if c was positive or negative, because it could have gone this way or it could have gone this way. But you can see it's not changed vertically, it's just moved horizontally. And it's not like stretched at all, it's just literally been moved across. Okay, y equals f of x plus c. So this one, for positive c, the graph of f of x is shifted c upwards, and for negative c, the graph of f of x is shifted c downwards. So you can see how that would work here. So not moved at all horizontally, and it's literally just been picked up and moved upwards. Y equals a lots of f of x. So if the modulus, this gets a bit more confusing, if the modulus of a is more than 1, the graph of f of x is stretched vertically by factor a. If 0 is less than the modulus of a, which is less than 1, the graph of f of x is squashed vertically by a factor of a. If a is less than 0, the graph of f of x is also reflected in the x-axis. So basically, whatever happened in these two still happens, but the negative means that it's also reflected in the x-axis. So you'd ignore the minus sign at first if it was a negative. You can see what that looks like. It's a vertical stretch. So the purple one's the original, black is the new one. You can see it was like this and it's been stretched. Y equals f of ax. So if the modulus of a is more than 1, the graph of f of x is squashed horizontally by a factor of a. If 0 is less than the modulus of a, which is less than 1, the graph of f of x is stretched horizontally. And if a is less than 0, the graph of f of x is also reflected in the y-axis. You can see an example of this here. It's been squashed. Okay, so this one, we're going to go over combinations of transformations. So you need to do them one at a time. Do transformations in brackets first. Here's an example. So, this is the graph of y equals f of x. Draw the graph of y equals 3f of x plus 2, showing the coordinates of the turning points. So first you do the transformation in the brackets. It's kind of like BIDMAS, BODMAS, whichever one you learn. Brackets first and then the rest. So the bit in the brackets, x plus 2. So think about f of x plus 2. It's been transformed by moving it to the left. So anything in the brackets, you change the signs in most situations other than the general calculation. So you move to the left. Then you're going to do transformations outside the brackets, so 3 over f of x plus 2, and you can see that that has squashed it horizontally. So the turning point, you can see how we worked it out when we moved it across. We moved the turning point across, and in terms of the squashing, it doesn't actually affect the turning point. So there you go, that's the end of the video. I hope you enjoyed, I hope you found it useful. If you've got any feedback, let me know in the comments. If you could like, subscribe, that would be great. And I will speak to you all later. Bye bye!